Action.
We're rolling.
Yo.
Okay, so we're going to talk about banked corners, which is horizontal circular motion. We're going to move this on. What we should be familiar with is that stuff going around in circles needs to have a centripetal force acting, and that's like the net force that acts on that body to cause the direction of its velocity to change, even though the speed, like the size of the velocity, stays the same. The centripetal force changes the direction of the velocity. We're going to have a think about why they bank corners. Like you're driving over the Takaka Hill, all of the corners kind of bank
No, they're not.
inwards. Well, there's one that doesn't, throws you off the side of the road.
There's 3 of them, sir. They're all in a row.
Anyway, they should all bank in, because that's going to help us go around the corners, even when it's icy or someone's dumped a load of milk on the road. It's really slippery.
Damn dairy
The
farms.
bank of the corner can actually help push us around. So to understand how that happens, we're going to have to do a little bit of thinking about the forces that are acting. What are the forces that are acting on something on a bank?
FG.
FG, what way does FG go? So we've got the weight force. FG is mass times gravity. That's a T. And another force, the normal force, which acts at right angles. F normal. And looking at this car, is it falling down?
No.
Is it flying up?
No.
So what do we know about the vertical component of the normal force then?
It's the same size length as the
weight force, and that's critical. That's one of the things that we're going to sort of use as a crutch when we're solving these problems, that the vertical component is going to be equal and opposite. It's going to be equal and opposite to the weight force, like that. And by cool little tricks of twisting triangles around on their edges, hopefully we can persuade ourselves that that angle there is the same as that angle down there.
Wait, down where?
That angle there is the same as that angle there.
Yeah.
Nah. Who's unhappy with that?
well, there's vectors.
I can accept it.
Okay, and so that means that the other component,
Green.
no, green, there is our FC. That's an unbalanced force. We've got gravity acting down, and that's balanced by the weight force acting up. We don't have a force pushing the car like into the bank, and so the force, the horizontal component of the normal force, provides the centripetal force. So even when there's no friction, even if we're on a completely icy, slippery surface, the bank of the corner, the horizontal component of the normal force, can push us around. So if it was a frictionless surface, if we were just stopped, we'd slide down. But if we're moving at just the right speed, that bank can actually push us around the corner, and that reduces the amount of friction that our tyres provide. So obviously in real life, like our tyres are providing some of the push going around, and the bank is providing some of the push. And if the camber of the corner is not quite right, you probably hear your tyres squeaking because they're pushing you a lot more than what they are expecting to have to. And when the camber of the corner is right for the speed, you should be able to go around without using your friction of your tyres, and the corner should push you around. Trigonometry, we often can know the size of the weight force. How can we use that to find the centripetal force? Weight is the same as the vertical component of the normal force. Got a tan at A. So what we can hopefully see is that tan theta, we know it's opposite over adjacent, so applying it to that triangle, tan theta has to be centripetal force over the weight force, and so often we can do something like centripetal force is going to be Fw tan theta. You don't get that equation or anything like that on your formula sheet. You're just going to have to draw diagrams, kind of puzzle out what the sensible way of solving whatever context they might give you is. But the key thing is that the bank of the corner pushes you around. Let's think about aeroplanes. Who likes aeroplanes? Oh. Damn.
Cars.
So straight and level flight, what are the forces acting on our aeroplane? So we got lift going, F lift and...
FV.
Sorry?
Oh, is it moving? It's going to be moving.
Yeah, it's flying into the board.
So no.
FG downwards. So we've got lift force going up, gravity or weight force going down. What about if we decide to go around the corner with our wee little aeroplane? What happens now?
F lift is like
F lift is created by the wings. The wings provide the lift force. And so if we bank our plane, that banks that vector. If we bank the plane, does that bank gravity?
Yeah.
No. Fg is still going down. And so if those forces were originally balanced, what's going to happen now? What's going to happen here? We break that into two components, the vertical one and the horizontal one. If they were
Gonna go.
originally balanced.
Yeah, it's gonna go that way.
So this is going to be the centripetal force. If they were balanced, is this one still going to balance this one?
Yes.
Yeah.
If they were balanced originally?
Yeah.
Oh no.
Nah, it's not. We've
Oh,
twisted that force off at an angle. That means that the vertical component, the greater that angle gets, the smaller and smaller the vertical component's
You
going
go
to
down.
And so your aeroplane, when you bank, if you bank really sharply, you might well drop while you're cornering because gravity is going to stay constant, but your vertical component is going to get less and less the greater you bank it. But you might choose, as you're going around that corner, you might choose to do something to like the wings to increase the lift force. So you might be like, damn, we're going to go around a corner, let's adjust the flaps, or I don't know however you do it on an aeroplane, so that you've made the lift force greater, and that might mean that the Fg might be balanced, and then that part there is going to be the centripetal force. So just depending on the context that you get, you might, if you started off with those two forces balanced, when you bank the plane, you might expect it to drop a little bit, or if you wanted to stay in level flight and go around a level circle, then you need to increase the lift force so that the vertical component of the lift force was still equal to the weight force.